This video is on 30, 60, 90 special right triangles. In this picture we have an equilateral triangle and we can split it into a right triangle. So a 30, 60, 90 triangle, a 30, 60, 90 triangle actually comes from an equilateral triangle. It's when we split that triangle in half, when we bisect the equilateral triangle to create a right triangle, we end up getting a 30, 60, 90 triangle. The blank is the blank of the equilateral triangle. The long leg, and we will use that terminology, the long leg, is the height or altitude of the equilateral triangle. So what that means is the height is that perpendicular aspect. It's going from the right angle straight up. That is the altitude. That's the height of your triangle. This is the long leg of the equilateral triangle. It's not necessarily the height of your right triangle, but it is the height of your equilateral triangle. So if we wanted to find the area of the equilateral triangle, we would need to have this entire base, which is the same length as the hypotenuse of the right triangle, because this is an equilateral triangle. And we would also have to have the height of the equilateral triangle to find the area of the entire triangle. So we have a right triangle that's been created here. In an equilateral triangle, each of these degrees are 60 degrees. So I know that down here, this is still 60 degrees. But because I have split this triangle, the equilateral triangle, into a right triangle, I have bisected this angle. I know that this angle up here in my right triangle is 30 degrees, because that's 60 divided by 2. I know that 30, 60, 90 triangle 30, 60, 90 degrees will create a triangle. So now to talk about the equations, there are two equations to use in 30, 60, 90 triangles. The first equation is talking about the long leg. Your long leg is equal to your short leg times the square root of 3. And then the other equation we're going to use is the hypotenuse is equal to your short leg times just 2. Because it's really the square root of 3 and then the square root of 4. In a previous video on 45, 45, 90 special right triangles, your leg and your leg are the same. But then you have your hypotenuse is equal to your leg times the square root of 2 in a 45, 45, 90. So it goes from square root of 1, square root of 2, square root of 3, square root of 4. So in those special right triangles, we're just using the square roots as it keeps going from 1 to 4. The square root of 4 is really just 2, which is why we just multiply by 2. Now to determine which ones, again, are your long leg, short leg, and hypotenuse, going back to saying the long leg is the height or altitude of the equilateral triangle, so this is our equilateral triangle. The height is our long leg. Our hypotenuse is always across from our 90 degrees, therefore our short leg must be this side of the right triangle. And another way we could know this, 30 degrees is your smallest degree. That means that the side opposite the 30 degrees has to be your smallest side. So this is called our short leg. And I will just use the word short for short. 60 degrees is your medium angle. So it's not as big as the 90 degrees. That's why the 90 degrees, your hypotenuse is always the longest side. This is the longest, but your long leg is your altitude. So this side right here, opposite the 60 degrees, is your long leg. And again, I'm just going to use the word long instead of the entire long leg. Then, of course, we have our hypotenuse, which is opposite that right angle. Now, if we notice in the equations, both of these equations, you have short inside of the equation. What that means is that you need to have your short leg first. So if you don't have your short leg, you need to solve for the short leg. So I'm going to make a note. If you have your short leg, you can find everything. But what you must do, you must find the short leg first. And again, the short leg is always across from the 30 degrees. So even if you don't have that equilateral triangle to notice which one is your long leg, you want to notice that your short leg is always going to be across from your 30 degrees because your smallest angle is opposite of the smallest side. So your 30 degrees, go across that, go to the other side. That's the side you want to find first. So with that being said, if the short side is what we want to find first, I'm going to call the short side x. If the short leg is x, I can find my long leg by taking my short leg, which is x, and multiplying it by the square root of 3. So my long leg will be x times the square root of 3. So x squared of 3. I can also find my hypotenuse from the equation, that the hypotenuse is equal to my short leg, again, which is x, times 2. So x times 2 would just be 2x. We would use these equations to be able to solve for the sides of the special right triangle. One of the reasons you want to know these two equations is because you cannot use Pythagorean theorem if you only have one of these sides. If it was a 45-45-90 triangle, you could still use Pythagorean theorem to find an additional side, but in a 30-60-90, you have to use these formulas if you want the exact value.